Okay, dear students, observe the question. Solve the following inequations by using an algebraic method. Okay, actually, inequation. So the meaning of inequation. If the expression is greater than 0, then it is called inequation. If the expression is less than 0, then it is called inequation. Then expression is equal to 0, then it is called equation. That's why if expression is greater than or equal to 0 or greater than 0, if expression is less than or equal to 0 or less than 0, are called inequations. Exactly, if the expression is equal to 0, then it is called equation. Suppose we have to take f of x is an expression. If f of x is equal to 0 then it represents equation. If f of x positive means f of x greater than 0, then it is inequation. If f of x negative means f of x less than 0, then it is inequation. Or f of x greater than or equal to 0, f of x less than or equal to 0 are also called inequations. Right? That's why you have to solve these inequations by algebraic method. Algebraic method means what? In algebraic way, we have to find the values of x. We have to solve the equation. Means what? We have to find the values of x. Bounds of x. For inequation, bounds of x. For equation, exactly x values are there. For quadratic equation, exactly 2 roots are there, if the roots are exist. For inequations, bounds of roots, bounds are there, intervals are there. That's why you have to find intervals. Now for the first question, actually this concept inequations, that means solution of inequations depends upon the concept on intervals of inequations. Already in the previous video that is there. That is a very important concept. Concept on intervals of inequalities. That is in the previous videos is there. And also quadratic expressions and quadratic equations depends upon the nature of roots. That is also one of the previous videos. Concept of nature of roots. According to those concepts, we have to do this question. Okay, right. Now the solution for first one, that is 15x square plus 4x minus 4 less than or equal to 0. That means it may be negative or 0. The expression may be negative or 0. Now we have to find factors for this. Here 16. That's why 15x square plus 10x minus 6x minus 4 less than or equal to 0. Take common 5x from this. Then it is 3x plus 2. Take common minus 2 from this. Then it is 3x plus 2 less than or equal to 0. Again we have to take common 3x plus 2 from this. 3x plus 2 into 5x minus 2 less than or equal to 0. Right? Now from this we have to write x plus 2 by 3 into x minus 2 by 5 less than or equal to 0. Now we are going to this is depends upon the concept on intervals of inequalities. That is, this can be right x minus of minus 2 by 3 into x minus 2 by 5 less than or equal to 0. This will comparing with the formula, if x minus alpha into x minus beta less than or equal to 0, then alpha less than or equal to x less than or equal to beta. then the value of x lies within the interval alpha and beta. That means x belongs to closed alpha beta. Here always the condition is alpha less than beta. Here always the condition is alpha is less than. Now this is the formula. Observe, since this is one of the parts of in previous videos, the concept on intervals of inequations. That's why if always alpha is less than beta, for always alpha is less than beta, if x minus alpha, x minus beta less than or equal to 0, then the value of x lies within the interval alpha and beta, including alpha beta. That's why x belongs to closed alpha beta. Like that, here minus 2 by 3 is less than 2 by 5. So minus 2 by 3 is less than 2 by 5. That's why alpha is less than beta. That's why the value of x lies within the intervals. That is minus 2 by 3 less than or equal to x less than or equal to 2 by 5. Minus 2 by 3 less than or equal to x less than or equal to 2 by 5. That's why x belongs to closed minus 2 by 3 to 2 by 5. That's all. So this is the solution set for the first inequation. For the first inequation, according to the algebraic method, we get the solution set, that is the x lies within the interval minus 2 by 3 to 2 by 5, including 2 by 3, minus 2 by 3 to 2 by 5. That's all. Okay, now we are going to solution for second question. Solution for second question. What is that? X square minus 2x plus 1 less than 0. X square minus 2x plus 1 less than 0. Observe. So the expression is negative and the x square coefficient is positive. That's why this is controversy, since this is the perfect square of x minus 1 whole square. X minus 1 whole square is positive. X minus LHS is positive. But given there is negative, that's why it is controversy. There is no value of x satisfy this equation. There is no value of x satisfy this inequation. Suppose put x is equal to 1, then it is 0. 0 less than 0. That's not correct. 0 less than 0. 0 not less than 0. 0 not greater than 0. 0 is 0. That's why that is not correct. That's why there is no value of x satisfy this inequation. Suppose we have to take in place of x minus 1. Minus 1 minus 1 minus 2 whole square 4. 4 less than 0. It is controversy. That's why there is no value of x satisfy this inequation. There is no value of x. There is no value of x satisfying this equation. Satisfying this inequation. Satisfying this inequation. That's why there is no value of x. That's why solution set for this inequation is null set. That is 5. That is 5. Kabatti. That's why it is null set is 5. So solution set, required solution set. Solution set is equal to 5. Are you clear? Solution set is null set. Since there is no x value satisfying that equation. There is no x value satisfying that inequation. So this is algebraic method. This is the algebraic method of solving the inequations. Definitely these inequations depends upon the nature of roots of the quadratic expressions or quadratic equations and concept on intervals of inequations. Already nature of roots and concept on intervals of inequations in previous videos. So those are very, very important concepts, especially the intervals concept is very important concept, since entire mathematics depends upon the intervals concept. Okay, that's it. Now this is the process. Okay, right.